Introduction to Heathenistics. Begin by defining heathenistics as an alternative mathematical system crafted to enhance computational efficiency in real-world applications. Introduce key ideas, including the unita particle as a conceptual link between charge and mass, and present the imaginary unit as more than a mathematical abstraction, positioning it as a force of subtraction and a foundation for heathenistic principles. 2. Core axioms of heathenistics. Describe each axiom as a pillar of heathenistic thought, introducing new concepts in mathematics and physics through unique interpretations of constants, units, and relationships. 2.1. Axiom of irrelevance. Propose that pi is an irrelevant constant in this framework, freeing calculations from its historical limitations. Introduce the diametron, a new unit of angular measurement, where one diametron represents a 180 degrees angle, redefining angular concepts without reliance on pi. 2.2. Axiom of torque. Define torque as a foundational principle for moving between linear and curved spaces within heathenistics. State that only work on I can yield a whole number magnitude, highlighting torque's unique role in mathematical motion. 2.3. Axiom of reflection. Introduce reflection as a core idea where I acts as a reflective operation rather than a tangible number. Describe reflection as a process that mirrors and integrates opposing elements, laying the groundwork for more complex imaginary real interactions. 2.4. Axiom of profoundness. Propose that all prime circumferences align to a line that resists harmonics, creating unique circumferences. Emphasize that primes are essential for efficient calculations of E, providing a structure that can't be retraced to a harmonic line. 2.5. Axiom of difference. Present the idea that all real numbers can be expressed as a difference of squares of I. Introduce specific examples, such as the 26th prime, 101, which can be represented as 10 plus I, 10I. 3. Imaginary unit and the unita particle. Describe I as a force of subtraction and the base unit of electric force, offering an alternative interpretation of I as a dynamic entity. Introduce the unita particle as a fusion of charge and mass, conceptualized as a normalized vector pair where the imaginary unit has an equal reciprocal function with magnitude 1 and a mass of E/2. Explain how I, through the axiom of reflection, I operates as a bridge connecting real-world physics to abstract mathematical structures. 4. Primes, harmonics, and number theory. Develop the theme of primes as harmonic primes, proposing that they each have unique, irreducible circumferences that do not coincide with any other harmonic. Explain that the distances between primes are determined by harmonic structures, and how these intervals serve as natural accelerators for calculating E, tying back to the axiom of profoundness. Suggest that prime intervals are intrinsic markers within heathenistics, contributing to a deeper understanding of number theory and harmonics. 5. Connection between linear and curved worlds. Establish the principle that the linear world serves as a foundation for the curved world, where Cartesian geometry transitions into polar representations through the properties of I. Define a ratio involving I that enables computation between linear and curved spaces with axiom of the speed of I, suggesting a normalized speed constant for calculations. 6. The fine structure constant and the unita particle's mass. Present the fine structure constant as approximately E/202, connecting it to the mass of 101 unita particles, which aligns with the mass of one electron. Suggest that the prime harmonics forming unita particles may collectively describe the proton, leading to a model where particle mass is built from harmonic components. 7. Conclusion and implications. Summarize the benefits of heathenistics in presenting streamlined approaches to calculations, eliminating redundant constants, and redefining primes as structural accelerators for functions like reaffirm the fundamental role of axioms in linking imaginary and real numbers, offering a new path for understanding mathematics in a computational and physical context.